The partial fraction decomposition of the rational expression p over q in lowest terms depends on the factors of the denominator q itself. This means that the denominator q of the rational expression p over q will contain only factors of one or both of the following types. It could be linear factors of the form x minus a, where a is a real number, or it could be irreducible quadratic factors of the form ax squared plus bx plus c, where a, b, and c are real numbers. A is not zero as well. And what I mean by irreducible just means a quadratic that cannot be factored down. Here I'm going to go over one example of non-repeated linear and repeated linear factors. So we're going to find the partial fraction decomposition of this rational expression. So the first thing I want to do is I want to factor this out. So I'm going to get x over the factored form of the denominator, which is going to be x minus 3 and x minus 2. And here, since I have two factors, I'm going to end up with two fractions, one with the denominator of x minus 3 and the other with the denominator of x minus 2. Now, since both of these factors are linear, meaning x to the first power, both of these terms up here are going to be constant terms. So I'm going to say some term a and some constant term b. What are they? Don't know, but I will find out. Now, what I'm going to do with this whole equation is I'm going to multiply it by the LCD, which is x minus 3, x minus 2. So this entire equation gets multiplied by the LCD. And when we do that, we're going to end up with x equals a x minus 2 plus b x minus 3. Now, there's two ways you can actually solve this. I'm going to go for the first way, and that works when all the factors are linear. Since these are linear, we're going to do it the way where we find out what causes each one to be 0. So what will cause this parentheses to be 0? And that'll be when x is 2. And so what I'm going to do is I'm going to plug in 2 for all the x's. Don't really need to do it for this one because it's just going to cancel out. So save some work. 2 equals b 2 minus 3. And so 2 minus 3 is going to be negative 1. So 2 equals b times negative 1. Then divide the negative 1 over. B equals negative 2. Now I'm going to do it again for b. I'm going to get rid of this. So what will cause this to be 0? That'll be when x equals 3. So I'm going to get 3 equals a 3 minus 2. And then this just cancels out, so no need to write it. And just do the arithmetic. 3 equals a times 1, which is just going to be 3 equals a. So there's my second factor. So I got a and b. Now I'm just going to go back up here and replace a and b. So my final answer is going to be 3 over x minus 3 plus negative 2 x minus 2. And here, for this one, is my partial fraction decomposition. Now let's do another one that's a little bit more involved. X plus 2 over x cubed minus 2x squared plus x. Same thing I'm going to do again is factor the denominator. And when I do that, I'm going to end up with x minus 1, and another x minus 1. So I got two repeated linear factors. So since I got three things going on in the denominator, I'm going to have 3 fractions. And the first is x, second is going to be x minus 1. Now the third is going to be x minus 1 squared because it is repeating. So since it repeats, it gets its own. And up top, again, since these are linear factors, and even though this is a quadratic, but it's a linear factor that's repeating, everything gets single coefficients of just A, B, and C. Now I'm going to find the LCD, which is x times x minus 1 squared. And I am again going to multiply the entire equation by the LCD. And when I do that, I'm going to be left with x plus 2 equals a x minus 1 squared plus bx x minus 1 plus cx. Now before we were able to set each one equal to 0 and just solve it, but this time we won't be able to do that completely. So I'm going to show you the other way, and that is by distributing everything out and equating coefficients. So it looks a little bit weird, but stay with me. When we work everything out, we're going to end up with ax squared minus 2ax plus a plus bx squared minus bx plus cx. And here is where we start equating coefficients. The highest exponent is a 2, so x squared. So what are the coefficients of x squared? On the left side, there are none, so we say it's 0. And on the right side, we have a and b, so a plus b, just their coefficients. And I like to underline to make sure I've already accounted for them. Now, next is x to the first. We go in descending order. On the left, the coefficient for x is 1, so put a 1 there. Done with that. And on the right, I have negative 2a. I have negative b. And I have plus c. And now the last is x to the 0, just the constant terms. So on the left side, I got 2. And all I have left is a. So 2 equals a. So right off the bat, I know what a is. It's 2. So now I need to find b and c. So I can take a, which is 2, and plug it into my first equation and find b. So 0 equals 2 plus b. Subtract 2 over, and I'm going to get negative 2. So b equals negative 2. And now I can plug in a and b into my middle equation and get c, which is what I will do. So 1 equals negative 2 times 2 minus negative 2 plus c. Now, negative 2 times 2 is negative 4. Double negatives make a positive. And I combine those. 1 is going to equal negative 2 plus c. I add negative 2 over, or I add 2 over, excuse me. And I'm going to get 3 equals c. So I have my a, b, and c. So now I'm going to go back up to my original, and I'm going to write or replace a, b, and c with the numbers I have. So I'm going to end up getting 2 over x plus negative 2 over x minus 1 plus 3 over x minus 1 squared. So this here is my partial fraction decomposition for the original expression.